Just as a continuation to our previous video, we talked about inscribed and circumscribed rectangles inside a curve. However, when we are doing the inscribed and circumscribed, all their endpoints just happen to be all to the right for one and just happen to be all to the left for the other. And that's not always the case. So sometimes they'll say, do 5 left endpoint rectangles or do 5 right endpoint rectangles. But if they say inscribed, you have to do whatever makes them inscribed. And so if you look here, this is a left endpoint that gives it the height to keep it inside. And it has to touch the curve. So I wouldn't choose the other one. You have to pick things that touch the curve. And this is a left. But if you come over here, a right is what makes it come inside. And so you have to be careful to make sure that you do that. And if you notice, the inscribed is going to be an underestimation, the actual area, if you look in the middle, and a circumscribed is going to be slightly greater. But again, notice the direction of the endpoint. Sometimes they're on the right, and sometimes they'll be on the left of the figure. It's whatever gives it that height and will make it either above or below the curve entirely. We're going to do a different type of approximation, not just left and not just right, not just under, not just above. We're going to do midpoint. And this should make sense for a midpoint. Our input into our function, it's going to give us the height we'll use for our base times our length times width, or base times height for your area. You're adding your two values and dividing by 2, so it's an average. So you're going to do the average value to plug into your f function. And think of delta x as like your width. So you'll have like your length times your width, or if you're looking at your base times your height, however you want to think about it for your figures. But that delta x is standing for that change in x, so how wide your rectangles are. And so you wouldn't have to be given this figure. If you were to just cover up that bottom thing, we would be able to graph sine, because we know how to graph sine from pre-calculus, and we'd be able to split it into 4 sections, 4 rectangles from 0 to pi. If you're splitting 0 to pi into 4 equal sections, they're each going to be pi over 4, split equally. And so if you look, when we graph this, each section goes up by pi over 4. And so like this width, or this delta x, is pi over 4. This delta x is pi over 4. This delta x is pi over 4. And this delta x is pi over 4. The base of each of those rectangles is pi over 4. But if you notice the heights, it's not a left endpoint, it's not a right endpoint, it's going to be a midpoint. And so we have to figure out what are these x values that give us those heights, because they gave us the x values that separated our rectangles, which are also very important. Okay, so if we look, you're basically going to be averaging 0 and pi over 4 to get the base of this first one. So I would do 0 plus pi over 4, and I divide it by 2. So we will use x as pi over 8 to get the height of this one. Okay, and then you would average pi over 2 and pi over 4, and you would be able to get 3 pi over 8 for this x value. And then you get 5 pi over 8 by averaging pi over 2 and 3 pi over 4, and you get 7 pi over 8 by averaging pi and 3 pi over 4. So what we'll do is I will call this my rectangle 1, rectangle 2, rectangle 3, and rectangle 4. And I'll find the area of each of those rectangles, and then I will sum them up so that I can approximate my area. And so my rectangle 1 is going to be my base times my height, so pi over 4. And your height is going to come by plugging in that x value, that midpoint x value. Okay, so in this case, we'll have pi over 4 sine pi over 8. And I would leave it like that because it's going to end up being a decimal approximation. Pi over 8 is not one of those common values we learned on our unit circle. And I will do this for all of them. They all are going to have that base of pi over 4. So I'm going to go ahead and write that in. And then I'm going to go ahead and write the values we found plugged in to my sine for each of them. And instead of approximating 4 different values and adding them together for an approximation, you don't want to approximate and then approximate to an approximation. Just add them up. We'll do approximation symbol. I'm going to add all those up. I would type in my calculator, just make sure that this is in parentheses. Okay, so that you don't end up sticking other values into your sine. When you add up all 4 of those sines, you are going to get, where's my calculator? approximately 2.052.